Hello, I'm Nicky Nicholson. I'm a PhD student with Alan Tucker, and I'm also a senior researcher at the Royal Botanic Gardens Kew, who are sponsoring my PhD work here and providing my time and a lot of data for me to work with. My overall PhD topic is about how targeted data integration can improve the application of machine learning models in biodiversity data. I started my PhD only in October, so quite new, so be gentle. And I'm really going to talk today about like a subset of the work that I've been doing, and that's how I'm refining some data so that we can apply a model with some tidier data. So if I go through these areas in the talk, I'll explain what floristic data is, because I'm sure that's a topic that not all of you have encountered. And the kind of applications, so why we're trying to work with this data type. The approach that I've taken, and then three different approaches in terms of extracting interesting features out of the data, and then some results and what we plan to do next. So a flora is a detailed account of the species of plants that are found in a particular geographic region. They're really detailed. They're expensive, long-term projects. They cover very, very precise descriptions, and they're aimed often at experts. So very, very dense in terms of the amount of data that they include, as well as enumerating the species found in a region and what those species look like. They'll say the distribution of the species within that region. And we've been conducting floras as a botanical exercise all over the world. Hundreds of botanists have been involved in these. We've many different flora projects at national level or regional level, so several nations working together. And they're really long-running projects, high effort to complete. Lots of people are involved, they last for a long time. We've got a real opportunity now to repurpose this data and do something much more interesting with it. When floras were conceived, they were published as books, and they were aimed at researchers in the field who would be armed with this book looking at plants. Obviously now we have the data digitally available, we can do much more interesting things in terms of looking at the patterns within that data. Kind of to prove how long-running these projects are, when you finish one, it becomes a news item. So it took 60 years to finish the flora of tropical East Africa. It started in the 1940s. And they thought it might take 15 years when they started that project. And you can imagine in the 1940s, it was an ink on paper publication, it wasn't a digital thing. They wouldn't possibly believe the things we're doing with this data today. And obviously they weren't at that time concerned with climate change so much as we are now. So this is a sample description. This is the kind of thing we get in a flora, and this is a description of an acacia species, which is a classic African species, the flat-topped tree that you see on the African plain. It's really dense. Don't try and read it all. It's aimed at experts, and it's written in this kind of telegraphic sublanguage, so short sentences describing structures. And I can highlight some of the plant parts there, so you can see that we can build controlled vocabularies because these appear in many of the descriptions that we have. And there is also something which might be interesting to look at. Like I said, it's quite early days yet, but these things appear in order. So they start off with the general description of the species at the top, then they go through the physical structure of the species, and then there's reproductive type structure, flowers and seeds at the end. So it might be interesting in terms of text mining as to whether we can use the ordering of the terms as just to give us some more data. So what these kind of descriptions do is they assert species traits, and that's that a species has a particular characteristic and a particular state for that characteristic. And this is something that biodiversity researchers are very much interested in, because they tell you something about the way the species interacts with its environment, and traits can be used to assert species holding some particular traits may be more vulnerable to decline than others, because it's the way that species interacts with its environment. If it reproduces very slowly, then there's a possibility that land use change and so on is going to affect that species much more than the one which is faster to reproduce. And we can derive those kind of things from these traits. And if we search the literature, there's many kinds of applications of trait-based analyses, but these are often done on hand-derived sets of traits. So researchers interested in a particular region will by hand go through those kind of descriptions and pull out the traits that they want to use. So they're based on relatively few traits and states. So I think this one had only a couple of hundred species and maybe half a dozen traits. When we're looking at the volume of data that's in the floras, those are thousands and thousands of species and dozens of traits, if not hundreds within each description. So to constrain the problem domain a little, when I'm just exploring the data, I work just on the seed statements, so the statements about the morphology of the seeds in the descriptions. And I pulled out and classified the terms using the directed graph, so that I could better work out what the terms were in the sentence. And I looked at finding qualifiers and pulling out measurements. So this sentence here is a seed statement. So seed suborcular in outline, flat. There's a measurement 1.62 millimetres long. Broadly winged, there's a trait that's qualified with the word broadly. And there's a coloration term that's brown. So I've pushed that into a directed graph. You don't worry about reading the labels in the nodes in the graph. But you can just see that all those terms are strung out together in a graph, and they've been classified with the key that you can see there. So this isn't the real focus of the research. This is to pull out these traits, but it allows us to kind of more easily query the structure of the sentences and to see what kinds of terms are being used in the description of the species. And it's quite interesting to look at the terms which are being qualified and pull those out.
Sorry, the size of the rounds, is it dependent on what?
The size? No, there's no. I just I applied a stop word list. So the ones in very small nodes are stop words, so they're not interested in terms of text mining. So I next looked at applying a glossary. So I have a digital format version of this book, which was authored by the people who are involved in one of these flora projects, but authored as quite a top-down approach. They talked to the people who wrote the accounts, and they said, we've been using these terms, and we write them down and defined them. So interesting things we can do now is we can compare. So we've got digitally the data, and we can say, bottom up, these are the terms you've been using. I've done a bit of digital reforming of the data that's in this glossary. So these are a couple of example statements from the glossary. So here we've got a flip in between a term which isn't very common and they prefer you didn't use it. So they say this is our preferred term for this state. And also something I've not yet looked at, but I think will be possibly of interest in text mining, is to look at these opposite terms. So we say that these two things are opposite, so they should appear in separate groups if we did grouping. So I've reformatted that glossary and put it into a JSON form, so I've got it in structured data here. So I can pull out any synonyms, so I can kind of look at the terms that we're encountering when we're preparing the data for text mining, and if they're synonymous, then turn them all into a preferred term. So I'm kind of cutting down on the number of terms that I hit. And I also looked at term qualifiers. So in red, the word obliquely is qualifying the term oblong cordiform. And the expert opinion is that often a qualifier is a kind of a weakener for that term. So if they were definite about it being oblong cordiform, they would have said it. They've weakened it by using a qualifier. So if we can identify those, we can perhaps give a score as to the rather just the presence and absence of that term, but the weight that that term should have in a model. And using that directed graph representation, then I've folded those qualifiers into the term that they qualify. So you have to forgive the ASCII art, but you can see that on the top level there's what was just a term broadly, and it was qualifying the word, the term winged, and it's been pushed in as a qualifier, so it doesn't really have a presence of its own anymore. And I've done a little work on measurement extraction, so detecting where we've got numeric measurements and pulling those out. So kind of a quick and dirty application of text mining on this kind of data, these would just appear as terms, and it would be much nicer when building a model to have a separate columns for dimensions and actually use those numeric terms in those columns. So in summary, this work has been about refining the terms using text mining. If you think the classic document term matrix that's laid out there, all this is what it's about is kind of crushing that term axis and making it a bit more strong. So not allowing terms which don't really add anything predictively to appear in that matrix. And these are some really preliminary results, but about 5,500 seed statements were put through this process. And we found terms from the glossary. Many occurrences of them, but almost 500 distinct terms, so that we can start to add some more data to the glossary to say that these ones are ones which are applicable to seed morphology. We found qualifiers, so we've managed to throw away many qualifiers that would have been present in a text mining model, so make that a little neater. And we pulled out these seed dimension measurements, so we can use those in later modelling approaches as well. That's it.